Claude wasn't the bottleneck. I was. And it cost me 2 wasted weeks to figure that out. 20 years an engineer and I use Claude exactly like I use Google. Type a question, skim the answer and move on. I figured I already knew how to do this. I was wrong. And right at the same time. And that contradiction is what this whole video is about. I'm Yogesh. I have postgraduate degree in mechanical engineering with 20 years of field experience. Watching from sidelines is different from actually building the skill. So I made a decision. I'm going deep on Claude specifically, and I'm going to do it in public. That means showing you the learning curve, not just the wins, what works, what doesn't, and what I had to unlearn to get there. This is video 1. First in the series is built around one question. Can an engineer with no hands-on AI background get real professional grade value out of Claude? My early answer is yes, but not by doing what most people do. Here is what I keep seeing in forums, in comment sections, on LinkedIn. Engineers and developers try Claude and get results that feel underwhelming and conclude that tool isn't as capable as it is or just isn't useful for serious technical work. I made that same call a year back and I think that was a wrong conclusion. The real issue here is that we are bringing the wrong mental model to it. We are trained to think in well specified inputs and expected outputs. And ironically, that instinct, which makes us good at our jobs, is exactly what causes us to hit a ceiling with Claude if we apply it in a wrong way. Let me show you what I mean. Claude is not a search engine with better interface. It's closer to a well-read senior engineer who can think through the problems with you, but only if you give them enough to work with. Think about how you would hand off a problem to a strong engineer on your team. You wouldn't walk up to them to their desk and say, write a sort function, here you go. You would give them context, what language, what function needs to handle, what edge cases are, what format output should take. You would treat it like a brief, not a keyword. And that's the difference. Let me show you exactly what it looks like. Create a function to sort numbers. That's it. And Claude will return something. Probably something that works. But you have no control over the language, the function name, the edge cases it handles, whether it includes documentation or how the output is formatted. Write a Python function called sort underscore numbers that takes a list of integers and returns them sorted ascending order. The function should handle empty lists and duplicate values, include docstring explaining parameters and return value. Display the code inline in your response with examples of how to use it. Look at what changed. You got the right language, the right function name, edge case handling built in, documentation, uses examples, and the output formatted exactly how you want to see. And that last instruction, display the code inline with examples, isn't a constraint on problem, it's constraint on output format. In engineering, we specify deliverable format, not just the requirements. The same discipline applies here. You are not just telling Claude what to build, you are telling it how to hand it over back to you. This is what engineers already know how to write. We write specs, we write requirements. We just forget to apply that discipline here because interface looks casual. It's like chatbot. 3 moments that actually surprised me. I want to tell you 3 specific moments from my first weeks, not tips, actual experiences, because I think you will recognize them. It asked instead of answered. I gave Claude a genuinely complex technical problem. It came back with a question instead of an answer. My gut reaction was irritation. I thought, I gave you everything, just answer. But when I read the question, I realized it had caught an assumption I had baked into my problem framing without noticing. I had that same experience exactly with one other category of colleagues, senior engineers who actually read the specifications before they start the design. It held its ground. I pushed back on an answer I disagreed with, told Claude its recommendation was wrong, and explained why. It didn't fold, it engaged, it updated where my argument held, and defended where it didn't, with new reasoning. That's not what I had expected from a chat interface. It felt like a technical discussion. Important caveat here, I'll be very blunt about it. It can also be confidently wrong. It will state something false with exact same fluent certain tone that it uses when it's right, and nothing in that tone tells you which one you are looking at. So verify everything consequential the way you will verify with any colleague's work. I was about 15 messages into conversation and working through architectural decision. The output had gotten noticeably better over the course of conversation, not because I had changed anything deliberately, but because Claude had accumulated context from my specific situation. That's when I understood the context window is a resource. The more you share the context you build across the conversation, the more calibrated the help becomes. It's the difference between asking stranger for directions and asking someone who has been sitting in car with you for an hour. Quick one before we actually move on. Which of those three have you already hit? Drop 1, 2 or 3 in comments below. I'm genuinely curious how common each is. Honest accounting. Here is where I ran into walls because I think this is more useful than highlight reel. Treating it as a workflow automation layer. Early on, I had tried to use Claude as logic engine for a simple internal tool, just through the chat interface. That's not the right architecture. There is a proper way to build automation pipelines using Claude through the APIs, and I will cover that later in this series. But if you are expecting to replace automation tooling through chat interface alone, you will be frustrated. Trusting numerical outputs without verifying them. This is where that confidently wrong problem from earlier bites hardest. Claude will hand you figures that sound precise, but language model isn't a calculator. It's predicting plausible text, not computing result. So some of those numbers won't survive the check. If one is going into real decision, run the math yourself. Last one, and this is pure engineering discipline failure on my part. A few times I got vague outputs, and when I traced it back, I hadn't defined success. I had described the problem clearly enough, but I had left out what good looked like. No scope, no format, no acceptance criteria. Claude can work with ambiguity, but it can't invade your definition of done. That part is on you. Specify it upfront, and outputs get sharper immediately. About a year of serious use now, the first 2 weeks of it wasted. After a couple of years of watching from distance, here is where I actually land. I told you initially, Claude wasn't the bottleneck, I was. Here is what that actually means. My ability to articulate the problem clearly, front load the right constraints, and engage with the output critically, that's the variable. Claude is largely constant. I was wrong that it would be easy, but right that I already had what it takes. That is genuinely good news for engineers. Every skill that makes us good at writing a spec translates directly working well with Claude. We already know how to do this. We just have to apply it here. What I would do differently from day one? Write longer first prompts. Not longer just for sake of it, longer because I would front load the context I was previously leaving to Claude to infer. That one shift is what turned those early underwhelming outputs around. What worked better than expected? Using Claude as a thinking partner for uncertain decisions. Describing a problem I was genuinely unsure about and asking it to help me to map the trade-offs. That mode of use produced most useful outputs by significant margin. Here is one thing I want you to carry out of this video. Claude is a thinking tool, not a lookup tool. The quality of your thinking going in determines the quality of what comes out. That's the whole unlock. Next week, I'm going after the instinct 20 years of debugging built into me. The reflex to trace every problem back to one deterministic cause. With AI, that exact instinct is what makes experienced engineers worse, not better. I will show you why.